Okay, I'm gonna share my screen first of all. Right, hopefully you can see everything fine. Yep. And let's start talk. Cool. So yeah, as Lee mentioned, I'm gonna talk today about getting ready for declarative UIs with Unidirectional Data Flow by using Kotlin Coroutines. And first of all, yeah, let me introduce myself. I am Raúl. I work at Twitter for the last 3 years and a bit, working as a software engineer, working in multiple feature teams. And yeah, you want to follow me, I write sometimes some articles about coroutines, about Lily Jetpack Compose and declarative UIs. So you will see anything that I write right there. And also, you are keen in seeing any code snippets from this presentation. Also, you can go to this GitHub user, which basically you will find everything in Git more than GitHub because I don't have a monorepo for that, but code snippets are there for you. Cool. So let's go to the agenda very quickly. I will start with a use case where everything hopefully will make sense to you. Then I'll start analyzing the system architecture of this use case. I'll start also adopting unidirectional data flow. And I will make sure that the point for me here is like, it doesn't really matter which architecture for your mobile application you use. You can still use unidirectional data flow, and that's the point. And then some implementation details, some lessons learned, which is probably for me the most interesting bit of this presentation, and why Compose can be a choice that matters to us on Android, specifically talking about. Finally, we have some next steps. Then also that's something we'll see. But let's see, first of all, this use case, which is basically this kind of sample app with a search engine from the Twitter API. As you can see, I have a few states right there for the UI, which basically starts with a loading spinner, some list of results, as you can see right there. And basically the user starts just typing any query of interest. And then we can see, first of all, I fail after the spinner. So we have this empty results test with this not being found. And when finally is working fine, I have some results. And then we can see the detail of this particular item. And if there is any problem, any error, then we can see and show this to we can render this to the user basically. So that's the basic use case. Then let's see what architecture I started analyzing right there. And for that, then we can start from this point, adopting this from this architecture. Obviously, because this can be actually any architecture that you can think initially. First of all, I use a separation of concerns. So I had the data layer with the repository managing two different data sources, the network and the database data source. Then the business layer, combining end results coming from the repository. This use case is requesting these results to the repository, getting the results back, and then getting those to the use case, transforming this use case, anything that is going on, and then passing this back by means of a callback initially. And then I am connecting this area, which is the main architecture area, with the presenter, which is the main responsible of the presentation layer. And basically, this is executing the use case. And from this point, everything starts. And in the old times, for clean architecture, we use callbacks all the way down from the use case to the presenter and so on, arriving to the view. As you can see, the presenter is written in Java, but the use case is in Kotlin. This is also interesting to be noted because, as you can see here, the view is connected with the presenter, and then the view is also written in Java. So we are talking here about a hybrid kind of application which combines Kotlin and Java files. And then the view receives the new data and renders anything that it needs. The user intention basically is starting typing a query of interest. And then I extracted any logic from the view. Then the view delegate starts the query. And then the mechanism starts. And reacting to those queries, we are having this system interaction. Then I see a few coroutines that I use over here in the different entities. For instance, into the data sources, I use suspend functions that return some results to the repository. Then the repository is emitting a flow that is passing also the results back to the next layer. For me, flow here is interesting because by using flow, I make sure that I can emit more than one value. In the other hand, suspend function only return one sort operation. That's one particular value. And that's why the repository is going to be the one emitting different values for that. Then the use case going to transform anything that comes from the other inner layers and then collecting the results back to emit or expose these to the other entities like the presenter. And that's basically it. But then how to get ready for declarative UIs? That's the main question we are trying to solve today. So first of all, you remember I say like I am using callbacks right there, but first question is, do we need callbacks or not really? Because if we are good with the callbacks, then why to do any effort to change and migrate those, right? So yeah, for that, we need to solve this question. Do we have any disadvantages on callbacks? So here we have our first guest of the night, that's Raúl from Street Fighter. Maybe if you're a bit old like myself, you can remember that. So he's doing a UCAN, and you can see that this UCAN from Raúl is creating a massive indentation. So basically, those are callbacks into callbacks, and those callbacks into more callbacks, producing a massive indentation that probably you cannot really read very, very good. And at this point, you created with Raúl, our guest, some callback hell. So basically, the problem here is, first of all, lack of readability. Second, if you have any problem here and you want to debug and fix the problem, you're going to have a very bad time to do that. So not ideal. Then also, the callbacks break a really interesting principle coming from functional programming, which is called reference transparency. This actually is the ability to make larger functions out of smaller ones through composition and produce always the same output for a given input. Very simple terms, if you are not familiar with functional programming, if you have a function and you have expected for a parameter, let's say you have a 3 as an input parameter, you expect always a 6 for this 3, and you change this 3 for another value. Let's say you have a 4 and you expect then instead of a 6, a 7, always going to be 3, 6, 4, 7. If you change those values, that means that you no longer have reference transparency working for you. And this is something that we want to keep here. The fact that we have a particular output always being there for a particular input. So do we have any consequences of breaking referential transparency? Yep. If we think in callbacks, we don't have a return value. That's the first of all. Second, callbacks use all other callbacks as an input parameter. So that means that when we go to the next callback, we need the previous callback to have something to pass as an input parameter. So this doesn't really make sense if we think in making this principle working for us, because we don't have something that is deterministic. So that means that actually at some point results can mutate, and if they do, then you can tell me how you can make sure that you are tracking this problem and you can solve it. So we have actually a lack of determinism. We cannot really predict what is going to happen from an input, basically receiving this and creating an output. So that's not happening. Are there any better alternatives to callbacks? So I will say, if we think in Kotlin, we could use, for instance, Stateful, that is always returning the latest value when it's any different. And also return those results coming from Stateful are immutable. And that means that Stateful, because it's the contract of the Stateful, is read-only. You only have getters. You cannot change the Stateful when you are creating this instance for the Stateful. Right? And this also proves that Stateful is deterministic by default, which means that if you want to produce a Stateful and you have already this instance created, when you are collecting the value of the Stateful, it's not going to be mutated. So you have different entities in between. If you have different layers, you emit one value here, point A, and you're going to collect in point C, going to be the same one. So this is going to be deterministic by default. And that means that actually we can just change those things that we have over there, and the implementation for me going to be just switching between the callbacks and creating those state flows instead of those. Nothing else. But also, important thing to notice here, you have hybrid applications like I have. you need to collect the Stateful because it's a coroutine in a sense. So that means that you need to collect this from another Kotlin file, because you cannot really collect any coroutine with a coroutine context into a Java file. You need a Kotlin file for it. Now let's adopt unidirectional data flow. And for that, we need to think, what's that? What does mean unidirectional data flow? Because that means like, what exactly? This is it. Now it's data flow. We have one only way to start, and we have one only way to finish. So this also gives us the concept of determinism. We start from one point, we finish to another point, and that should be all. Right? Something like we have a UI, we intend an action, we transform the results from the action into a state, and this state is rendered as a UI. So that means that we're going to start again from the UI, intending this action, transforming the results into a state, and then rendering a new UI. So all the time going to be the same, starting from the UI and finishing into the UI. One state, one UI. If you want to produce a new UI, you need a new state. And with that, you're going to make sure that the UI is always representing a state. If you are processing all different states and you are ready for states, you are ready to represent different UIs, and that meaning rendering different UIs as well. Right? If we are thinking in creating those into classes, for instance, I just started from my imperative UI, intending an action, so triggering the view delegate, that is a delegate of the view, triggering those actions to the presenter is executing the use case. Let's assume the use case gets the proper data from the data layers. Then we dispatch this state once the use case is handling and managing and modeling this state for the UI. And then the stateful handler is communicating the state to the imperative UI, and then rendering this into the imperative UI. That's the first step. And that means that we can actually make sure that imperative and the declarative UIs can coexist. We can start playing with the different imperative UIs as they will with declarative UIs. Basically, we do that. We make sure that we can just switch and change the imperative UI with a declarative UI. As simple as that. That will make everything ready for compose in that case. So advantages of that, flexibility. Because if we change one imperative UI with a declarative UI, you're going to have everything ready to switch them back if you have a problem. You need to fall back to the previous implementation. You have now your system ready to do one or one another. Also, layers composition. If you create small entities to process different things along the way, you can just switch the different things that you have there and creating by means of composition over inheritance. Let's see some implementation details for that particular case. So first of all, if you think about it, I use data sources with the network and the database. So what I use, if you remember, were suspend functions. Once the operation returning some results from the network or the database. So something as simple as that. I use here dependency injection by having the Twitter API. That is just client for getting some responses, something to check if there is internet, something to manipulate the different requests and responses. And then the function that I have right there is just a search function that is a suspend function, no blocking, and also going to be authenticated and passing a query of interest. And then I will process that. And I will return those values with an operator called either. Either comes from the Arrow library, which is a functional programming library. In the left side, for this either operator, I have, if I have any problem, let's say a throwable or an exception. And in the right side, the successful result. That means a list of tweets that I'm expecting to have. Either is actually very similar to calling result. So if you're familiar with calling result, this is essentially the same. Then if I want to do the same with the databases, the DAO for me is this. I am using here the room library. You could use something else, of course. And I'm getting the results in a descending order to pass from those tweets IDs and then retrieving that and getting those list of tweets that I'm going to use later into my query. Then the repository, going to use suspend functions and flows. So you remember, I'm going to return those results back to the repository, and then we're going to start emitting different values for the flow. The repository contains the data source for the network that we already know, different tables from our DB, and a few things there, some mappers, some combination of tweets and query at the token, and so on and so forth. And something called task threading that I use just to wrap the different dispatchers. Then the functionality gonna return a flow that is a list of tweets by passing as an input with IDs. They're gonna pass the list of strings that are there. Right, and now we have different possibilities. If we think what we need, let's say we have this spam function, and then I have inside a functionality returning a flow. Is that even possible? Can I return a flow inside as a spam function? So I would say no, this is not really something you want to do. It won't compile either, because spam functions, if you think about them, they need another spam function to be able to run, or they need to be inside a coroutine context or scope. So you can just simply change that and use another spam function inside, and that can be right. You can just return a list of tweets into a spam function, and this will work nicely. Then this is as simple as just returning this with this spam function, and that should be it. Then let's see a different case for the flow. Let's say we have a flow builder that is going to emit different values. If we have the operator emit all, that's gonna work, because this one is gonna emit all the values that the DB has observed, and gonna emit all the values from this open stream. And this is a good example if we think in a poll, when we are refreshing maybe every 30 seconds with a background call to the backend, and you want to refresh the UI with the results. If you have an open stream, you can refresh the UI anytime that you have a new result. Then the flow on operator gonna be the one responsible of making sure that the block for the flow is using the IO dispatcher, input-output dispatcher for our coroutines. Then this is also valid. We could use the flow builder with a one single emission. That means as a spam function there as well. Another possibility is emitting, first of all, the values that we have for the dirty values from the DB. And then if we refresh those values from the network, we can emit again. So we return this flow with a list of tweets. And now let's see for the use case overview what we have. So we're gonna collect the flows. The flow is gonna be passed firstly with the callbacks. And now the use case with implementation of the callback is a use case with a callback as a parameter. We have the tweet repository and then the coroutine scope. And the scope that they use is basically a UI dispatcher with a supervisor job. And why a supervisor job? The answer is here, to avoid side effects on cancellation. Because in my case, I can have more than one thing behind the scenes. So what I prefer is to use a scope plus a supervisor job. That means to avoid other streams cancellation. Just to see that visually, let's say we have the scope plus a supervisor job, and I cancel job one, or maybe better said, job one throws an exception. Maybe you don't want to cancel job 2 and job 3, but you have scope plus a job, then if job 1 throws an exception, job 2 and job 3 gonna be canceled automatically. Maybe you don't want to have that because you have some processes that you want to keep when this situation happens. That's why I kept the scope plus a supervisor job. Right, use case implementation. First of all, I introduced the use case with the execute method, passing the query parameter, that's a string, and the callback. And then the cancellation method, if I want to cancel the scope. The execute method is going to start the callback initially, so showing the loader, the indicator, and then starting the scope with the launch. The repository is going to search for this query of interest, and then I'll map any operation if I want to do any particular computation that the business logic requires. And this means that I'm going to use this into the computation dispatcher, because obviously I don't want to block the main thread of the application. And for that, we can use flow on again. Flow on is an upstream operator. That means that anything you have at the top of it is going to be into this computation dispatcher, including the map. Then catch, going to catch any problems that we have over there, any exception, and then collect, going to be the one for any particular stream that we are iterating to, passing those results to the new callback. That's what I have at the time. I can change and I can use launch in instead of launch from the scope. And this is a very nice operator because it's super convenient. You see, on each is basically replacing collect, and launching is replacing launch. The different thing here, apart from the syntax, is the fact that catch, because it's also upstream, gonna catch any problems that the on each operator gonna have. So you want to catch an exception there, you will have it here as well. And then I will cancel at some point my particular scope. So here we are. Now let's see how we can synchronize with the UI. So the use case with the flow, we are collecting things and we are passing back those things to by means of the state flow to the different entities until we arrive to the view. So basically we are replacing all the callbacks all the way down to the view. Basically we remove this use case that is a bit legacy and we create a new one. And basically we remove the callback. We don't need this anymore. And I'm gonna pass this state flow that's going to be shared across the different stakeholders. Unused state flow can be passed across Java and Kotlin files. So you can use it safely into Java files as well. So the use case flow, gonna use a Tweets UI state that is a state for my UI. I'm gonna pass this dimension of get state flow, and I'm gonna rely into the state flow, which gonna make sure that the state flow is read only, because state flow is the interface that is getting just getters. And then for setting that from my use case, I'm gonna start initializing this instance of a state flow by using mutable state flow. And then I will expose this by means of the state flow. State flow is an interesting basically entity because also has by default distinct altitude change. So basically, if you have different states, it will produce an emission of the value. But if you emit something that was already emitted before, then this altitude change will stop there and won't emit this value. So you have to take care about it. Also, you need always to pass the latest value. That means you always have one value, at least one. So you better have something for the very initial state, despite it's an idle state that doesn't do anything, but you need it. Then I modulated that for the UI with tweets UI state by creating a data class that is a list results UI state with a combination of tweets. And this is very important because this altitude change only will have any effect if you use val. Why val? Because val means that is read only or immutable. If you have var, there is no way that either compose or the altitude change of the state flow will recognize that this will change, because you didn't pass anything mutable. So you need to pass something immutable for this to recognize that is actually there is a change there. So yeah, better do it. Also, error UI state gonna be the same, passing a message and show this message to the user in the way that we want. For the empty UI state, something similar to that. We're gonna just say, hey, there are no results for this query, unlike you. For the loading UI state, we want to show something to the user. So basically the spinner or whatever you want to show, no message right here. That's why it's an object. And the same with the idle UI state. Maybe we don't want to show anything and just put some message, some initial message. Now we're going to start removing the callbacks. So basically the search tweet, we're going to search for the query. And we'll start the onStart operator from flow, which is very convenient as well. We're going to pass the state flow by means of the value functionality of the loading UI state. That's going to be the first step that we're going to start every time that the flow starts. And then for any iteration of this flow, we'll check if we have any results. If it's empty, we'll pass this. And if it's not empty, we'll pass different tweets. As simple as that. And then the catch will pass the error from the message and will be shared across. Here we are. So we have this all the way down from the use case to the presenter to the view delegate to the state flow handler, and now we need to collect it. So to connect those different entities, basically the presenter contains the use case, and the presenter also executes the use case. So basically I don't need the callback anymore. We can get rid of this code that is already deprecated. And as you can see here, this is a Java file. So I am exposing this state flow to the next entity. I mentioned this function, get state flow. Now the view delegate is going to do exactly the same. It's connected with the presenter and it's exposing this to the next entity to work with. And in this case, I use a fragment from my UI, but you could use an activity, you can use a custom view, whatever you prefer. And I injected here a view delegate and the state handler and the state flow for us to handle those different state flows. And every time that I create the view, I start initializing the different flows and the views. So basically initializing this into my entity, and then collecting things by means of this state handler. Every time that there is an iteration into my flow, that means the state flow, I'm going to handle the UI states for me to render anything that is valuable for me. Of course, into a scope, because we need to collect it. That's why we need a Kotlin file. And now let's see a few cases. Imperative stateful UI rendering. Why stateful? Because imperative UIs need to handle a state. And we'll see why that means really. So we have the use case that is dispatching the state, stateful handler is communicating the state, and the imperative UI is rendering that state, right? So far, so good, nothing really complicated. So handle those states, this is a extension function that I am passing this state for the UI inside those. And I am, first of all, processing this list results UI state. So I created another extension function that is show results by passing the collection of tweets. And this one has a few other functions. Let's say, first of all, we have a loading spinner, this one that is indicating to the user that something is being loaded. And that is visible now, but we want to show the results. So maybe we don't want to show the loading data spinner. So we need to hide it. That's the first state we need to manipulate. Second state, have an error message. Maybe it was visible as well. So you need to hide it. And now you want to show the results. So you need to make visible this recycler view with those elements that you come into your recycler view with the different things and items. Then finally, you need to also pass the tweets that you had passed by means of the state handler, containing into the state flow this UI state, and passing into that a collection of tweets that are going to be reflected into the adapter with the view holders. One tweet, one view holder. So that means that we are updating this adapter as well. A few things here. So we are manipulating a few states and a few widgets for our UI. Right. Now we have the other states that we need to also handle. So I created a few more extension functions, and I won't tell the different details for these implementation ones, but basically you can imagine if I show the loading, I will show the loading and I will hide the other elements. I will, for the next one, I will show the empty state and I will hide the other elements. I will show the error and I will hide the other ones, right? And for the idle, I don't need anything for my imperative UI. I just make nothing there, right? So let's see what's the difference between that and the declarative stateless UI migration. Stateless because declarative UIs don't care about state. They care about rules and making the rules visible for you. And that means, having a contract. And then that means stateful handler dispatches a collected state, rendering those declarative UIs and making those ready for you. First of all, I created an entity called search composable UI, apart from the delegate and the handler. And first thing we need is into our XMLs with the layouts on Android. For interoperability purposes, you need to, first of all, add the compose view. They're going to be the one that you will use to start migrating. You will need an ID for this compose view that you will use in a moment. Like that. Into this particular fragment, I will find this view. I will get the compose view. And then I will pass the compose view to use it when I need it into my search composable UI that I created. Something like that. I will use assign this value and I will use later on. Right. Initializing flows with the view delegate with the state flow, and then when we get the state flow, we'll pass this search composable UI and we'll use that when we need it. So search state handler, gonna use the search composable UI and the state flow. Again, this is just initializing things into my state handler. and processing the different states for the collection. So when we are processing those, equivalent to the previous implementation that you saw, but now I am using Search Composables UI for start composing my views with the UI state. So I initialize this into that as well. I get the compose view reference for the content. And now we're gonna start playing with it and where the magic starts. So the compose view, we're gonna start setting the content, and the first thing you need is a theme. Now we need to think a little bit about coroutines, because this is done in a way that is very similar to coroutines. Why is that? Because if you remember, coroutines and suspend functions in particular need to run inside another suspend function or a coroutine context. Likewise, we need a theme to be the first of the tree. And from that point, starting to build our composables. So initially you have a material theme, that's the default one. Preferably you want to have your own theme with your own colors and different things. That's why I create my own tweets with search theme. So yeah, let's assume we have the material theme that is our custom one ready. And now we can start creating different composables using states UI and passing the UI state. Now we'll start with the state and doing different things and rendering and be prepared for that. That's the first composable. And let's see a few alternatives that we'll have to create those stateless declarative UIs and why, trying to solve this question of why this is stateless. So I removed this stateful handler and I created something probably more simple. It's called UI state handler. You will see the difference in a sec, and we'll handle those UI states in the same way to render the declarative UIs. And of course, this is going to be exactly the same, but changing one entity with one another. Again, doing composition over inheritance and removing the state handler, adding the search UI state handler. And with that, passing the compose view as we already did, and just having the reference with the Stateful, and we don't have to pass any reference from the fragment as we did before. So that means we have the Stateful there. And now I don't need to pass the UI state in the states UI functionality, the composable. Because into that one, I have already my Stateful that by means of this convenient functionality that is provided for Stateful, that is called collect as state, it will provide a state that is ready for composables to be processed. This is coming from the library, of course, from Jetpack Compose. And this state gonna have our values to be passed and be processed at due time every composition that we use and have. So, yep, now we are going to render this stateless UI. And what we have for our stateless UI is basically passing the UI state. We're gonna process the first one, list results UI state, by rendering a tweets grid. This grid is being composed by a collection of tweets. Inside this grid, I have a vertical grid with a maximum of width, a combination of different columns or cells. This can be also adaptive, and this is actually it's not a stable version. So basically, this will change in the future, but you can imagine a combination of cells and then a collection of items. The count gonna be the number of items that you can imagine, and the item content with the trailing lambda gonna contain the tweets that we're gonna get the index from, and then we'll pass for this particular index that we are using right now, the tweet, and I will start creating the different items for every one of the cells. I created something called Tweetbox, that is a custom declarative UI that contains a tweet, and also on tweet click. That basically, as you can imagine, is a function. So we are passing here a higher order function. What we have into this higher order function is just like we are passing this. That is another function, simply returning a lambda that is getting us to the detail of the tweet. Nothing else. We are navigating to that, and we are passing the lambda to be processed. Right. So the tweet box gonna create a box that contains the on click that we pass by means of this higher order function. And then the box is containing this particular setup with the alignment and everything like that. Into this box, I use a column. Here's where we can see the UI that I want to render. So this contains an image, separation, and a text. So the box contains a column. If you're familiar with Android, you will think like this is equivalent to the linear layout. Exactly the same, we use a column here. And the first element that we use is actually the image. So the image is containing the URL, because probably we don't want for every recomposition to load again the URL and then loading the image. We can just use the operator remember coil painter from the library, and this will keep for us the URL. Then also super interesting and important, content description, because we are developing for everyone and accessibility matters. We need to use content description all the time. Please don't do the trick of using quote, and add some valuable information for our users. Now, for this variation, we need a spacer with a height, and then the center text. That is just something that we want to render for the username to be shown. And with that, we have the box with the column and the image, the spacer, and the text. Now, for processing the rest of the items, I just created so I extracted the string from those for the file of different strings, and I rendered the same with the same component that I used, center text, for the error and also for the empty UI state. Right, so this element can be reused very easily, and it's as simple as just having a text message and modify it with the padding, the style of it, and the overflow. You want to have an ellipsis or something like that. Then for the latest item, it's exactly the same. So the other UI state is basically a top text. And just to finish, cleaning up resources. So you have any UIs, remember to put all to nullable, otherwise you will have memory leaks. Canceling different scopes, also to avoid memory leaks, and also to run startup concurrency and make sure that everything is canceled on due time. Destroying the views, again, the same, destroying different views. We don't want any view to be living after destroying our views. So when destroying the views, canceling all the different things and destroying the different views that we have. And with that, we have this ready with the Unidirectional Data Flow and the Declarative UIs being there. Something like that. Start typing is the top text that I showed you earlier. I am typing something here, so you can see this is working with the different elements that I already created. This is the different boxes that I created with the 3 different elements going to the next screen. And yep, that's basically it with Compose. Now let's see the probably most interesting bit of this presentation. Hopefully you are still awake there. Interoperability. Why this is good for us and is very interesting in Compose in particular. So I don't need to tell you what Compose view is because you already saw it during this presentation. But the good thing here is like we could go both ways. So you have all kind of application and you want to start with from some point. You can use Compose view for that. On the other way, you have a new screen. You want to start from scratch and you want to use Compose directly, you can do that. And maybe you want to reuse a super custom view that you created that is super complex or has a video player that is complex to reproduce and create in Compose. You can use Android view and use the same. So Compose is really prepared to start interoperating between the different worlds, the imperative and the declarative world. Also, recomposition runs multiple times, and that means that we need to make sure that our views are prepared for the states as a single entity. Because if we rely in different orders of operations, then probably you will have a bad time sometimes. You wouldn't know what is going on and why. Then remember, we'll save our previous state in the view, because thinking in the case that I mentioned earlier, maybe you don't want to load an image over and over. You just want to do that when the URL has changed. And for that, remember, we will save you some time and resources. Then another very interesting concept is called composition local. That basically is the simplest way to pass data flows to the tree and its children. So what does it really mean? This kind of definition. So let's think right now that if you remember what this process tells you, we are starting a composable from a theme, and then we have a first composable. Then you want to create different entities by means of these composables. So you're creating, let's say in this tree, in this also called slot table, a tree with different elements. So you want to pass something in one of the branches, in one of the leaves, to go to this leaf over here. Then you need to pass this by means of the function from the top one to this one, if you want to apply this to this particular one. And to do that, you have two ways: do it manually or using composition local. So basically, composition local is the way for you to use dependency injection without exposing a value through the whole tree, directly to the one that you needed. Then avoiding also using this value in recomposition for the different elements of the tree. Also, composables should be side effects free. What does it mean that? Thinking in side effects, a side effect is something as simple as requesting something to the network, doing a DB operation. So a composable is a UI. UI normally runs in the main thread, and side effects should run into a background thread. Otherwise, you will block your UI, so don't do that. So that means that you want to run side effects. You could do that, but then you need to use something called effects handler that is provided by Compose as well. It's a tool that anything that happens after recomposition can be run there, only after recomposition. And there is a lot of documentation. So the resources from Google are great on that. So just have a look and you'll see what you can do there. Also, Unidirectional Data Flow likes states, but really likes states. That means that you better are ready for states, or you're going to have a bad time trying to render your declarative UIs. Then thinking in imperative against declarative programming, this is a very interesting kind of mindset changing, because we come from a world where we need to set a visibility, enabling something, disable something, hiding this, hiding that. And now we don't care about it anymore. We just have it or we don't have it. What does it mean? Declarative UIs don't need to care about this is visible or not. They just need to care because we use the slot table or a tree, that anything that you want to render is in the tree at the time you want to render it. So when we want to render this particular grid that I showed you today, then you need to render this into the tree, nothing else. But then after all of this, why compose? If we were so happy rendering massive layouts, creating endless files with 1,000 lines of custom views, which is beautiful. So if we think about it, so different pros and cons, Compose runs in parallel and very frequently. So that means that it's meant to be really, really performant. And this is gonna save you some resources as well. I'm gonna be very fast. So it's convenient long term. Also, the classic views can run in sequential order. So if you need to rely in a particular order to render a particular view, you can do it with classic views, but you cannot do it with Compose. Think about it. Compose is stateless. That means that don't care about states, but cares about immutable data. That means that by having immutable data, we can actually make sure that everything is deterministic, and we can predict what we have into our composed views. Classic views are stateful. So that means that everything can change. You need to handle probably different states from different views. And let's think in something big. Let's think in a XML layout where you have a ton of lines, custom view, different switches, and at some point, some of the switches change. In the other view, also something change. And then you need to make sure that everything is combined. How will you do that? Because from the top to bottom, probably you cannot really control it. Or you have an orchestrator that is having endless operators to control everything, which can be a bit harder to manipulate. So this is manipulation, and that means mutation. it mutates, you cannot predict it. So you don't really have a way to know what is going on there into this massive view because it has mutated. Then compose only runs in Kotlin. So better be migrating everything if you have still Java files. Classic views on the other side, they can use Java or Kotlin files. Obviously, because classic views belong to the OS of Android. So for sure won't be removed, but yeah. Now, thinking about different improvements, performance improvements is something that Compose really achieves. So basically, we're going to have parallelization in the rendering, in the UIs, and it is meant to be really, really fast. Now it's already fast, but in the future, probably going to be even better. So we'll see. Testability, because by using Compose, we are going to make sure that everything is tested, because if everything going to be immutable by default and deterministic by default, that means that you can actually test every single layer. And when you arrive to your composables, you're going to know that everything was tested. So you can actually make screenshot testing for your UIs or specialized testing for also your UIs, and the rest should be properly tested if you want to. Reusability of UI components, because you can create very generic components in Compose and can be very easily extended and added to the stack. This with imperative UIs was super difficult to achieve. So this is a great advantage of Compose, actually. With very little lines, you have many generic things that you can create. And then finally, for me, experimentation of new ways of working. Because if we want at some point to render a particular UI into your app, your backend can just tell you, I want for this screen, this in that way. And you can render this super easy because you're going to have instructions and you can just make sure that the UI is printing this as you go. Of course, this with imperative UIs could be achieved as well. But the way to do that, it wouldn't be so easy, to be honest. And then just to finish this presentation, next steps. Start adopting explicit state declarations today. Otherwise, when next month happens and Google releases Jetpack Compose officially with the first release candidate, you will be in a rush to remove and change everything to state declarations. So yeah, that's basically it for today. Also, I have some articles that I wrote, so you want to read more. The first 3 ones are about this presentation, but in more detail. And also speaking about Stateful, the 2 of the series plus this latest one that is a separate one speaks a bit further about Stateful. Also, special thanks to Nick Butcher, who reviewed those slides back in January. Now the presentation has evolved and have a few changes, of course, and updates. Thank you to you, and thank you for inviting me today to Brighton Kotlin. And if you have any questions, now is the time for questions.
Wow, thank you for that. That was amazing. We've got a couple of questions in the chat, and just to kind of follow on from the links to the articles, I posted a link to your site in the chat so people can go directly there if that's where the articles are. So in the chat we've got in the Compose documentation suggests to avoid architecture patterns like MVP. What do you think about that?
Yeah, 1 second, let me drink some water.
So yeah, in the Compose documentation, it suggests to avoid architecture patterns like MVP. What do you think about that?
Yeah. This is not actually the first time that I received this question, so I know already the answer. Yeah, well, 2 things here. First of all, I kind of agree, like MVP maybe is not the ideal scenario to use Compose, but at the same time, maybe MVVM isn't either. What I mean here, using Compose and using Unidirectional Data Flow is how you do things more than what architecture you use. Also, if we think about MVVM, that is the existing pattern that Google recommends, in a way, this is recommended because the view models and the things that Google created are under MVVM. If they will still keep the let's say, a use case they want to use, is going to be equivalent to the view model. So in a sense, it's similar. If you remove the placenta and you have the view model instead of the interactor use case, it's the same. So yeah, don't use it because you can use something else. But if I was you, I will use maybe MVI, which is the best pattern to have unidirectional data flow. Really, a bit more complicated. You need to do more things like reducing states and everything like that. But it's up to everyone. And the unidirectional data flow can be just basically done and manipulated in a way that you can do as you prefer, basically.
Okay. It might be the same for this question as well, but what would be the major benefit of using Stateful instead of live data?
Yeah, except the initial state. So the main benefit, first of all, is like with the Stateful, Google won't deprecate live data. That's the good thing. When live data going to be deprecated, you're going to be safe because you've already migrated. That's the first thing. They promise they won't remove and deprecate live data. But we know Google. If you trust Google, up to you. Other than that, you can do everything that you do with live data in Stateful. And even more now that they created a few helpers for the different lifecycle architecture components and everything, where you can use and you can stop Stateful in the background with those helpers that they created. So you have essentially the same. The thing is like live data is something that was created for facilitating work on Android. To be honest, I never used live data myself. I know about live data because I did a few presentations last year and I had to investigate it myself. So it doesn't really give any advantage compared to Stateful, and Stateful can do those things plus more things. If you need only the use case for the live data, then it's fine. Also, live data is very prone to errors because it runs in the UI thread. So if you need to do something in the background thread, you're going to have about time, you're going to block your UI. So you're going to have more drawbacks than benefits. So I don't see a clear advantage of using live data, but convenience and don't want to adopt anything new.